This video reviews the math concepts and changes in velocity, which is also known as acceleration. One way to look at acceleration is a car that is either approaching a red light and having to slow down, or a car that's at a red light and has to speed up once the light turns green. In this instance where a car is increasing its velocity through acceleration, we call that a positive acceleration. Wherever an acceleration is causing an object to slow down, we call that negative acceleration. We can calculate acceleration by knowing 4 pieces of information. First is, what is the final velocity of our object, the initial velocity at its start, and 2 time units. A lot of times we get an overall time of the travel of the vehicle. It's usually listed as 1 single time. We apply that to the equation A for acceleration is equal to the final velocity minus the initial velocity over time. Let's look at this with a textbook example. A jet airliner is at rest on a runway. At takeoff, it reaches a velocity of 80 meters per second straight down the runway in 20 seconds. What is the jet's acceleration? We know this is going to be positive acceleration because the jetliner was at 0 meters per second when it was sitting on the tarmac. When the engine started increasing their thrust, it pushed the airplane down the runway, and as you can see in our graph here, you can see how positive acceleration would be shown of speed versus time. Now, velocity versus time is a familiar graph. Knowing the information from the problem, we can actually go through and solve for acceleration. Again, the acceleration is equal to the final velocity minus the initial velocity all over the changes in time. We can plug our information from the problem. The final velocity was 80 meters per second, and the initial velocity was 0 meters per second because the plane was not moving. It did that change in motion in a total of 20 seconds. Go ahead and subtract 80 from 0. We get 80 meters per second over 20 seconds, which we know reduces to 4 meters per second squared. You might be wondering how we got those units for acceleration. Acceleration equals some units of meters over seconds squared. Well, let's take a look at the units in a very simple problem. We took meters per second and divided by seconds. We can simplify that. That is equal to meters over seconds times seconds, or that is equal to meters over seconds squared. Let's look at another example. A skateboarder is moving at a constant speed of 3 meters per second in a straight path. He comes to a complete stop in 2 seconds. What is the skateboarder's acceleration? As we can see in this problem, we have negative acceleration, as you can see by the graph. We can apply our acceleration equation. Acceleration is equal to the final velocity minus our initial velocity all over time. So the final velocity was 0 because they came to a stop, and the initial velocity was 3 meters per second. And remember, the time that it took to slow down was 2 seconds. If I simplify this, 0 minus negative 3 is going to be negative 3 meters per second, and it's all divided by 2 seconds. Take that, put it into the calculator, we end up with 1.5, negative 1.5 meters per second squared. The next problem says, acceleration makes amusement parks fun. The top thrill dragster at Cedar Point can reach 200 kilometers per hour in 4 seconds. What is its acceleration? First thing we have to worry about are the units. 200 kilometers per hour is not easily put into 4 seconds, so we should convert. To convert 200 kilometers per hour, we know that in 1 kilometer there are 1,000 meters, and we know that in 1 hour there are 3,600 seconds. We plug that into our calculator, and we end up with the 55.56 meters per second. We know this is correct because our units cancel. Kilometers in the numerator here cancels with the denominator here. Hours in the denominator here cancels out with the numerator here. So our units at the end, meters over seconds, shows us the velocity of the top thrill dragster at its fastest part. 55.56 meters per second. Applying that to our acceleration equation, A equals the final velocity minus the initial velocity over time. We know that the top thrill dragster reached a final velocity of 55.56 meters per second, minus 0 from the start, all over. Total time it took for it to reach the top speed was 4 seconds. Take 55.56 meters divided by 4 seconds times seconds. And that is equal to a positive acceleration of 13.89 meters per second squared. Now see if you can solve the more practice problems on the sheet. Check in science class to see if your answers are correct.